Hello everyone, this is our final lecture on fossil fuel energy. Our previous lecture was an alternative or renewable energy, and this is the complete opposite. So here we're looking at global energy supply from 2003 to 2015. Each color represents a particular type of energy source. So here we're looking at hard coal, natural gas, this brown color, crude oil, the gray color. These three make up about 80% of the global energy supply. Yes, we are increasing solar, wind, and hydro and biomass, but that still only comprises about 20% of the global energy supply. So still we have a lot of catch up to do, a lot of market for non-renewable renewable energy. So what are the three types of fossil fuels? They are mainly coal, oil, and gas. Coal still dominates the energy source in Eastern Europe and places like China. Oil is the major source for the world now. Natural gas, which is methane, it is the most clean form of fossil fuel compared to coal and oil, and it's most preferred. In places like the US, we see that natural gas has sprung up more, there's more production, and as a result of that, the coal has taken a hit. So, what is this fossil fuel? How does energy flow through these fossil fuels? So, millions of years ago, basically, these plants and trees that were harvesting the energy from the sun, they basically died and they got buried deep underneath the subsurface. So, under immense heat and pressure and time over millions of years, this organic matter basically, under this pressure, formed these deposits of coal, oil, or natural gas underneath the surface. So basically, when we drill, we are basically finding these pockets underneath the surface and extracting that deposits. So basically, what this tells us is the deposits are finite. At some point, we'll run out of this uh, underground deposits of this fossil fuel, which is why we need to look for more renewable energy. So let's look at the pattern now of oil production and consumption in the U.S. Here in this bottom graph here, let's focus on this color. We're looking at from 1950 to 2010. Oil production in the U.S. Increased up to 70s, and there was a big a crash of oil production. And as you can see, we are sort of going downhill from that. There's a little bit of production that has picked up because of production of oil from the state of Alaska. But if you look at consumption, here's the graph, the orange color, and despite the crash of oil production in the 70s, our consumption of oil or addiction to oil has increased nonetheless. But despite these hiccups, we see that we're increasing oil more and more in the US. What's happening recently? So this is a more recent graph from 2007 to 2016. We see that in the 2007 2008 we had a big market crash. You see, this is the oil price in barrels. So the oil is traded in barrel. So the price here around 2000 2007 8 was about almost $130 per barrel, and it crashed. It came down to almost $30, $40 a barrel, and it has picked up. But what's happened is that uh, there's been more domestic production of oil in the US. So when there's more supply than demand, the prices eventually go down. So here we are in the 2016 and 2017, where the oil prices are almost half of that what it used to be. And this is reflected of on if you go fill up your cars in the gas stations, you see that the prices are much lower compared to the time about 2010 to 2015 period. At the same time, there's less demand. As I said, there's the economies of the European and developing countries are more weaker, and at the same time, there's also more energy efficient vehicles. So if you look at the oil, U.S. production of oil, you see that the production were going up, but there's slightly declined uh, coming towards 2016 in Canada as well. So because of this increased production of oil and gas in the US in the last 5 7 years, over almost the last decade, uh, it actually caused the oil prices to go low. And now, because of low oil price, the production has decreased. So there's actually uh, about 250,000 oil and gas workers have lost jobs globally. So here we're looking at the supply and demand of oil. The dark blue is the supply, and the light blue is the demand. So yes, the United States production has surged in recent years uh, with the boom of shale oil. We'll talk about that a little bit. um, and as a result, there's more supply of oil than there's demand. So as a result, the prices are low. Now, the downside of fossil fuel and drilling is that there's a lot of chances of oil spills, right? So, as from an environmental perspective, these are really dangerous for the environment. This fossil fuel drilling accidents can basically pollute an environment, marine or both terrestrial, for years and years to come. So, if you look at all of the liquid spills from pipelines from 1990 to 2011, these are all of the liquid spills, and you can see the major pipelines here. And again, these are usually not reported, but the spill has been occurring in every year on millions of gallons. There are some major ones. You might have remembered this one, the Deepwater Horizon burns in 2010. There's a huge leakage of oil shell, but also a lot of people lost their lives in here. But the leakage of this oil caused basically irreparable damage that we even see the signs today here. Now, another form of energy that has recently, over the last 5-7 years, gained attention is tar sands oil. So this is found in Canada mostly. It's a combination of clay, sand, water, and bitumen, which is basically a heavy black viscous oil. So to get this bitumen oil, it kind of looks like this. You have to have a basic, very complex process to extract this oil from this mixture of clay, sand, and water. And to do this, the process is very damaging to the environment. Right now, the Alberta in Canada sits over a huge, vast reservoir of this tar sand oil. It's the third largest proven reserve, 170 billion barrels, um, and only 16% of the reserve is underdeveloped in Alberta. So again, they're producing a huge amount, 1.6 million barrels, that could increase to about 3.5 million barrels per day by 2020. So again, Canada, particularly Alberta, is sitting on this basically gold mine for the near future. But at the same time, as I mentioned, it has a lot of environmental degradation, environmental damage, because of the complex mechanism by which we have to extract this oil from these sands. Now, you might have heard of the Keystone XL pipeline. There's an assignment forum for this. You'll read about more about this. But basically, all of this oil that Canada is producing, they need to transport it to sell it to other countries. One way to do that is to transport basically all of this oil to the different ports, places like Houston, Port Arthur in Louisiana, and this is where the Keystone XL pipeline comes in handy, because you can basically transport this oil, and then from here you can ship it out to European, Asian countries. But this has been a big debate. Uh, these are already all of the existing pipelines, and this is what the Keystone XL pipeline would be like. The previous administration, under Barack Obama, declined and basically said no to this pipeline, but President Trump, our current president, has revived this Keystone pipeline. So we'll have to wait and see how this goes forward, if the construction actually holds up. Another method is called hydraulic fracturing to get oil or gas. This is basically drilling down into the earth, and basically you release this high pressure water mixture in this rock fissures, and then this pressured water mixture basically releases the gas inside. So as you can see, this graph here in the US, natural gas production has really increased since 2004 or 5. You see this huge production from this hydraulic fracturing. It is also known as fracking. So this huge production of fracking natural gas. And a main reason why coal plants and coal has not done very well recently is because that we have been producing a lot of natural gas in the US domestically. So this is much cheaper, this is much cleaner than coal, and as a result, a lot of the coal miners have been put out of job, and coal has basically the coal mines have been closed. And so we hear this current administration talking about bringing back coal jobs, but if this natural gas production keeps up, I don't see a reason how we can still bring back coal jobs. So again, currently fracking in the US, there's about 300,000 fracking wells, 4.3 million barrels a day. So again, huge production. And again, looking into the future up to 2040, we see that this fracking is still uh, projected to account almost 70% of all of the US oil and gas production. So, with this, it's almost impossible to see coal, coming back as it did, back in the 70s and 60s. However, the downside is, again, with this process like fracking, you're putting this mixture underneath the ground. People who are living near, this fracking sites, they see the methane gas coming up in their water sources, and you can see this tap basically lighted, when you put a flame there. So again, there's potential hazards, health hazards with this type of, drilling for fracking. Now, finally, we'll talk about the Arctic region. Again, this is the Arctic Ocean. We talked about how the Arctic is losing sea ice. Every summer, the sea ice is getting thinner and it's losing more extent. And when that happens, more, all these countries are trying to get access to this ocean bottom where potentially there's a huge source of oil and gas. So, uh, this is a map showing estimated undiscovered oil. Almost 13% of all of the global undiscovered oil across the Arctic. Same with undiscovered gas. About 30% of all of the global undiscovered gas is mostly in this Arctic region. So again, if the sea ice is declining and more countries are drilling here, potentially this is going to be a new source of energy here in the next couple of decades to come. And companies like Shell have already been spending a lot of money. Again, it is not hard. It is not easy to drill in the Arctic. It's a very harsh environment. But companies like Shell has already been investing a lot of money to see if they can start mining this pristine environment. And again, this is comes at a price. This is one of the most untouched environments in the whole world. So we'll have to see whether if this drilling keeps up and continues, what are the environmental impacts that could potentially be incurred with this kind of activity. And again, to outline the side effects of fossil fuel burning, again we realize that air pollution is one. Here, this is a great smog of 1953 in Britain, which is never talked about in the media or anything. But there was this basically smoke and pollution in the winter caused a huge number of deaths in a place like the UK. In the US, we have something called the Clean Air Act that was installed in 1970. It was a federal law that was designed to control air pollution, basically particulates, sulfur dioxide, carbon monoxide, and nitrogen oxides. And again, we can see that this is the concentration of all of the carbon monoxide since the 1980s here. And when we have a law that is in place, we see again this was established by the Environmental Protection Agency, the EPA. And we see that the concentration has declined over up to present, right? So again, the cleaner air that we breathe in today is much thanks due to this act called the Clean Air Act that was established in 1970. And again, we see that all of the sulfur dioxide, volatile organic compounds, and nitrogen oxides, as soon as we started having that law in 1970, we see that there was a huge decline in these pollutants, right? So coming from industries, coming from efficient cars, and we do a lot of monitoring for the cars, right? We all get stickers for our car. We have to monitor every couple of years. So again, when these laws are in place, they work. So this graph shows that. Again, the emissions have been declining, but that doesn't mean that our production is declining. So here it's our gross domestic product in the US. So despite the decline in the emissions, our consumption has increased, our vehicles have traveled more miles, and we have increased our gross domestic product. So just to show that just because we are putting laws to control emissions doesn't mean that we have to minimize our other activities. All right, so that concludes our fossil fuel energy. And again, this is our last video lecture. So again, thank you all for participating, and hopefully these lectures are helpful for you guys. Thank you.